Okay, fantastic. Welcome, everybody. I'm going to talk a little bit about Ethereum 2. Last time I covered it very fast. I covered it with another, session. So this time I said I want to go slightly into, well, Ethereum 2 from the perspective of a developer. What's going to actually happen for you? How is your experience as a developer in Ethereum is going to change, right? All these days you might have done something with some ETH client you have connected, whether it's like whether it's like Get or like Teku or like whatever it is, or I don't know, Nethermind is there also there. Yeah, so there are some clients. So yeah, you might have used all these clients and then seen that okay, this is where we have to interact, or you would have used your own internal like development purpose stuff like Ganache and all these things. But at the end, if you wanted to go to production, you must connect to one of the real Ethereum nodes. So that's where you start to see that okay, there is some effort in productionizing stuff. So now, how will that experience change when you go to Ethereum 2.0? So, first of all, I want to say that Ethereum 2.0 is just a name somebody in the community at some point of time gave the name to the entire effort, to the entire multi-year upgrades of Ethereum, which is which one wanted to move to proof of stake, and then two wanted to scale somehow. We don't know how, right? Now we have some idea how do you want to scale, but this is actually the crux of the effort. So somebody named that Ethereum 2.0 and it stuck, right? So what we have now, what you guys use is Get and all these things, it's Ethereum. And what is going to come, and like what's there as Ethereum 2.0 is going to actually do a merge with what you have today, and that's going to be called Ethereum. So Ethereum 2.0 is actually not used. This term is not used anymore anywhere in the developer community, except that some people who have used to this name, they suddenly, if you tell them there is no Ethereum 2.0, it's only Ethereum, so they get slightly confused. So I just want to make sure that it's going to get called Ethereum. It's Ethereum. All of them is Ethereum, right? Okay. So I'm going to talk a little bit about myself. My name is Zahoor. I don't know. It's very hard to see me in Indian circuit, but I have been there for 25 years doing something in somewhere, in some MNC or some startup, whatever it is. Started in blockchain somewhere around later part of 2016. And I have, over the time, I have worked in Ethereum Foundation, Swarm Foundation. Now I'm working as part of Prismatic Labs, which is actually building a client called Prism, which is one of the dominant Ethereum 2 clients, or like it's going to be Ethereum client, right? So okay. So I just want to make sure that we all understand what is Ethereum and like how it's going to change today and tomorrow. So if you take the Ethereum today that you all know, that actually consists of two things, right? One is it has an execution engine, it has EVM, and then the data associated with it, right? For the EVM to actually work on the data, right? Your transactions, your state, your receipts, your logs, and all these kinds of stuff, everything like put together somewhere in some format in a DB key value store. And there is EVM which actually uses this. We call this execution, right? And then we have this like proof of work. This is just, a consensus algorithm, right? If you have ever worked on distributed systems, you would have come across consensus algorithms like Paxos and all these other variants that you have. But proof of work was the, you cannot say first, but I think the first one which sort of proved that, yeah, you can get internet-wide consensus on something. This is something called as Byzantine fault tolerant. That means in internet, people can be malicious actors, can be there, normal actors can be there, and all these things. So even if you have malicious actors, it will not affect the consensus. That's how it is. That's what it is. So you all know proof of work. I'm not going to go too much into that. That's a consensus algorithm. Why we need consensus? Because this execution or somebody or a miner has created a block, and we all want to agree on that. Okay, this is going to be the next child of what we have today. What is the tip today, right? So we all have to come, all Ethereum nodes that is running on the internet has to come to some consensus that, yeah, this is the block that's going to do. Why? Because in proof of work, more than one person can, or like more than one miner can actually create two valid blocks. And the way that these blocks slowly percolate in the internet, let's say a miner in Taiwan has created a block, and a miner in like somewhere in California has created a block, and they started to transmit through their P2P connections, and slowly it comes to some point, and then like half of them are using this one as the child, and half of them are using this one as the child. That's a fork. That's usually a fork that happens. It happens in Bitcoin or any kind of stuff, right? And then what actually happens is that at some point of time, this fork has to merge, right? Or one of them has to be abandoned, and other one has to be considered the the chain, canonical chain. And like that's how proof of work works. I mean, I don't want to go into much deeper. I think you guys know these things, but this is a consensus algorithm. Okay, that's all, right? So what it is there today is an execution engine, proof of work together put into one client, and like packaged and given to you, and you guys actually run it nicely, and it keeps on syncing blocks, keeps on doing blocks. If you actually run a miner also along with it, it might produce blocks also, right? What is going to come later is that what we have is Ethereum today minus proof of work, and then plus proof of stake. This is another kind of algorithm which actually provides very similar or like same or like same safety mechanism to doing consensus properly. but it doesn't use any mining, any power to mine. So that's just going to reduce the consumption of Ethereum, the power consumption of Ethereum by 99.993%, right? That's the expected one. So it's actually good for us, good for the environment. That's why we are doing that. That's what is the Ethereum that's going to come after merge, right? And then, okay, so I want to actually introduce you to this, like two terms that we will be using. So these terms are these are the terms that will get slowly percolated down when these things release outside and people come to know about these things. So the Ethereum today minus proof of work will be called the execution layer, the things that which execute, right? And then this consensus layer will be, a separate thing that will be, that needs to be run along with this one to actually have a full Ethereum node, right? So you will have a software for only execution layer, which does not have proof of work. And then you will have a software which does consensus. Now, how proof of stake works, I think most of you know, but I will just give a very small this thing. What actually happens is that in actually proof of work, you have incentivization. You don't have de-incentivization, right? So you have to, do all this heavy duty stuff to actually get rid of malicious actors. But in actually proof of stake, there are like different variations of proof of stake. People come with different, like Byzantine, Istanbul, consensus algorithm, all these kinds of things. But basically what happens is that you have some people who run a small software, which can even be run on a Raspberry Pi. You run a software called, validator, instead of, actually running, in the old Ethereum, you run miner, right? You start CPU mine. It starts a miner, right? So instead of that, you are going to run a small software called validator. So what you have to do is this: as a validator, you have to submit a deposit in Ethereum. So right now it's actually 32 ETH. So you have to put a deposit. Once you put a deposit, you become a validator. That means now you have the power to actually look at the blocks that come in, and you can see whether everything is, all the signatures are right, everything is valid, and all these things. You can actually give the execution layer to check all the stuff in the execution layer, what it does today. And then what it does is that it sort of it says, yeah, so I have done the validation. It's called attestation, right? And then some validator will be randomly selected and will be given a duty called actually it's called actually a proposer. So only that guy can propose the block, and there will be only one block that will be transmitting all over the network, not like multiple blocks, which is there in like proof of work, right? And like all these guys have to just look at the block and then say, yeah, this looks good, and they attest. If they attest on a block that is not good, they will get slashed, right? So their 32 ETH will slowly get slashed based on some slashing algorithm. So that there are different slashing conditions. So basically what proof of stake is, that it's like a bunch of validators validating on the block. Like somebody produces a block, they all come and say, yeah, this block is good. And once they all say good, the entire system accepts the block, right? That's the proof of stake, right? So, but there is a large difference between how it's implemented today in different systems like Solana and other systems, and in Ethereum. I will not go into much detail. So this is a diagram that I stole from Danny. Danny is the head of the research in Ethereum who does all these things. So he does nice diagrams. So I like this diagram. So I just stole it, but I gave him source. So you can go to the source. You can find the entire this thing also. So what you see on the top is what you know as get today, right? So you have an execution layer which has all the data, parent hash, state root, receipts, all the fee kind of things, everything set there, and then you have a block. You have the transactions that you are like, and then you maintain, and then there is like a state tree and all this kind of all this stuff, all the data. That's an execution layer. And then you have a proof of work on top of that, which actually provides consensus. It just gives you consensus that, okay, if there is a problem in accepting blocks, I will make sure that, okay, that all of them will accept the same block. That's the only thing that it says. Like, just actually think about leader election, right? Like we all vote to somebody, and it's like, okay, so if you all say, okay, Mr. A is going to be the president, Mr. A is the president, and that is being said to everybody in the town, and like everybody will know Mr. A is the president, right? It's like that. So, and then what slowly started as the effort, the first thing that started is independent to this, right? Is called something called as beacon chain. This is the first step towards moving to proof of stake, right? So what actually beacon chain is, right? Now, I already have a chain on the top. Why we need one more chain? You can actually think of beacon. It actually launched into mainnet. I think in 2022? In 2020 December somewhere. We just now last December we celebrated 1 year of beacon chain. So it is running for 1 year in mainnet. So what beacon chain actually does is that, but not many guys run beacon chain. You don't have to run because you have get now. So you do all your like DApp only needs get. It doesn't need beacon chain right now, right? But it started because we want to make sure that it works fine in mainnet. It does the thing what it does in mainnet, and that's how it started. So beacon chain is also a blockchain, right? So there are they actually transmit consensus block, among the network, among the beacon nodes, right? So you have a software, usually E2 client that usually comes as beacon node. So let's say you start beacon node, so you become part of the entire consensus network, right? So that also has a chain, that also creates blocks, but that has blocks that has attestations. What you can see, I don't know whether you can see my cursor, but you can see all these attestations here. This is the deposits that if anybody is coming and joining, he has to deposit 32 ETH to process deposits. Exits, if anyone want to exit is not implemented yet, so it's not there. You can't take that amount right now, but it's coming. And it also has a lot of other things like here, execution layer, but all these things are actually doing only one task. They are actually doing the work what like proof of work did. It actually tries to bring something to consensus. Right now, there is actually nothing to bring to consensus, right? So there, right now there is nothing to bring to consensus, but the beacon chain is running. And there are different algorithms, there are different uh, things that people want to tune and things like that. But you can join, you can attest block, you can attest the consensus block, only the consensus block, and then say that, hey, yeah, I attest to this block, I actually do this and things like that, right? But it does not, it does not do anything useful in that sense. It just brings something to consensus, right? Which is consensus blocks, right? So it says that after this block, only this block is attested by most of the validators. So in Ethereum, it's actually, like if 2/3 of the validators attest on like the block that you actually proposed, then it's considered as like, okay, that's the one everybody is going to use, right? So it's actually only creating consensus of the consensus blocks, right? What you're going to get next is interesting. So when the actual merge will happen somewhere around, some people asked when it'll happen and all these things. We are aiming for Q2. Again, this is the most complicated hard forks or a fork you will, we have ever done on Ethereum. This will be the most complicated one, because you have to merge two chains which are actually running in two different algorithms. And it's like actually changing the engine of Boeing 747 when it is actually flying, right? You are just throwing out proof of work and bringing in proof of stake inside, which is like, the engine which actually runs it, which gives the consensus. Otherwise the entire chain will stall, right? If you don't bring something to consensus, the chain will stall. Like Solana stalled for 72 hours. I don't know whether anybody read the news, right? It stalled because it cannot come to consensus, right? There is something there that it stalled. I'm not against Solana or any other chain, but I'm just saying this is example, right? Okay. So what we will be doing is that we will be at this point in time, at some point in time, I'll explain this in a procedure. This is slightly complicated. So just assume that at some point in time, we will just push the execution layer block inside the beacon chain block, right? And use the beacon chain block to arrive at a consensus of which execution layer block that I should use, right? So this is, okay, again, if it's slightly confusing, I'll go it again. What will you do at some point in time is that, until this point, the consensus chain here is just arriving at consensus about the consensus block. That, okay, the next consensus block is this. Next consensus block is this. Why? Because you have to store certain things like attestations and all these things, and you have to actually transmit to everybody. And everybody, I know if I attest something, I as a validator, I have to transmit all these things to the entire thing in the network. And my attestation, I don't want to give like one single thing. It has to go as part of a block, right? So then you can easily say that, okay, 2/3 of the people attested for this block, so I pick that. More than 2/3 attested for this block. So it's usually 95, 96% of people, of actual validators attest this. Okay, can anybody say how many validators are there currently running in actually beacon chain, in this chain, which is actually not doing anything, or it's doing something, but it's not, it's not taking any block. Can you say that how many number of validators? Okay, so can anybody say how many number of validators does Solana has?
I think they claim to have a couple thousand, but that could include people who are, it doesn't include like unique validators. That they, according to Anatoly, he said it's really hard in the Solana ecosystem to distinguish a unique validator. So it's like somewhere in a couple thousand, but unclear how many are unique. Yeah.
Okay, so I'll give you a number here. It's actually closing the 300K here in this chain, which is not doing anything.
Wow,
Imagine when it actually goes after the merge. After the merge, now you don't have proof of work. That means all the miners, Ethereum miners who are there in Iceland, who are there in some some country which has very low power or a lot of hydroelectric power, whatever, all these guys are going to go to some other chain because their job is over. I'm sorry, guys. So that's what will happen at this point. At this point, what will happen is that both these things will actually merge to become one, right? So it is actually a chain inside chain. So this chain, the top chain will be the beacon chain. It's exactly like a blockchain. It will actually point to its parent and ancestors. It's exactly like a blockchain. This chain can have like forks. So right now, beacon chain has like forks, and then it joins because it has a fork choice rule. Okay, can anybody say what is the fork choice rule in the current proof of work Ethereum?
I know you guys know, someone knows this.
Yeah, I think it might be slightly difficult to.
Yeah, it's not longest chain in Ethereum. It's slightly different.
It is actually the longest chain.
Well, technically it's ghost, right?
Right. So technically, which chain has been seen by most of the network? That's what I'm going to take. It means, right? So what it means as the longest chain is that, let's say you are at the block A, you are at block B. Now what you are doing is that some part of the network has seen a block C and some part has seen another block D. And now these guys will be looking for, I mean a parent or like a child of C, which says C is my parent. And the guys who are actually following D will be looking for a child which says D is my parent, right? So and then actually the second miner or then the third miner can be following this thing, either of them, right? So let's say if it follows a C, so what it will do is that it will create a block called D that will actually point C as my parent. So that will get propagated. And let's say if that gets propagated to 50% of the guys who have D, then 75% of the entire network knows that you have to follow this network CD instead of, or like CE, or instead of D something, right? So it's basically longest chain there, right? The fork choice is like how much has the network seen. It's exactly the same thing here. How much I mean, if there are two competing blocks, how much of this block is being seen by most of the network, right? And that's where attestation comes into picture. So you know, I would say the only big difference is that in proof of work, it would be much more often, because there is actually no rule which says that only one selected miner can actually create a block at a given point of time. It says anybody who comes with the answer first, I will take it, right? So most of the time there will be a fork, and then there will be a join, because it will be a reorg. You know, they will say that, okay, we'll abandon this one, and they'll follow this chain, right? So it's called actually a reorg. Now here I mean, like, at least in like proof of stake beacon chain, what we do is that we do at every epoch. So, okay, I'll come to epoch later. So at like every some X amount of time, we will say who is validator that's going to propose the block next, or like next 32, whatever, right? So next 32 blocks, who are going to propose? We will give the name of the or the ID of the validator. And that validator is supposed to actually create a block, a consensus block initially, right? So that validator will actually create a block, and it will, you know, like, you know, send it to the entire network, and then the network will actually have a look at it, and then they will see how many other validators attest on that, right, on that block. They say that it is okay, fine, okay, all the BLS signatures are okay, exit deposits have been processed properly, and it's actually everything is right. It actually came in actually the right slot, you know, right? Like, I mean, it's actually a fixed time in, like, you know, it's proof of stake here. So all these things, and then it will say attest on that. And if the attestation is more than 2/3, then that block becomes like sort of confirmed. Now, what is the big difference between proof of work and here will be, right? In actually proof of work, the longer you wait for a confirmation, let's say, you know, in the first block, if it is confirmed, it's actually confirmed. But you have to wait for some more blocks. You know, people usually wait. If you go to exchanges, they don't give you in one confirmation. They say we'll wait 15 confirmation. That's because of the, you know, that there can be a reorg, right? And your deposit might not come. You know, that block might not have been accepted, right? So they want to actually wait as long enough, like 15 or something like that confirmation. After that, there is very less probability of becoming of actually doing a reorg. So then they will say that, okay, now I agree, right? But in proof of stake, what happens is that so there are, like, as I said, there are like checkpoints, and like at one stage you say the block has come, and then at like another point you say the block is justified. Justified means, okay, it's like confirmed, but it's not finalized. But at the, you know, second epoch, you will actually finalize it. That means the chain is committed, that's all, right? So you don't it's like that's the place that you say it's done. You cannot do reorg and all these things after that, right? So this is what is going to actually happen in the merge. In the merge, the execution layer will go inside, and execution layer, you know, execution layer will use you know, the beacon chain to, you know, send the blocks. Here, what it does is that the execution layer, let's say if it has a miner, it will create a block, and once it creates a block, it will give to the it will actually use its own P2P network to transmit the blocks outside, right? So that the block gets transmitted to all the nodes in the internet, right? But here what will happen is that it will create a block and give it to the consensus layer. And consensus layer will actually carry the block of the execution layer inside the block of the consensus layer, right? And will come to a conclusion. Whichever consensus block has come to a conclusion, that block is actually finalized, right? So you understand that? So that's the difference. Instead of using proof of work, and then coming to this thing, but here you actually create the block and give it. Now this causes a lot of problem, right? Now you have two things now, two blockchains, two softwares, right? So the execution layer is actually get that you will run. You have to run one more software called E2 client, right? Like some clients, it can be Prism, it can be Lighthouse, it can be, I think there are a lot of other things. Yeah, I don't even remember the names. There are like at least 5-6 clients that are working on this. There's one on Go. We are Go guys. There is, I think Lighthouse is Rust. The consensus client was, I think it's called Teku or something like that. Yeah, Teku. That's in Java, for the enterprise. And there are other clients which actually do in JavaScript also. So yeah, but yeah, that's what it is. So you have to run, two things. This is the conceptual way that how it will be done. But then, yeah, so I mean, after the merge, it looked like one chain, but it's actually a chain inside a chain, right? This, this bigger chain is actually a consensus chain. So this is like how it will be there. Like you can say deployment diagram or whatever it is. I don't know. So you will have an ETH1 minus proof of work, which we call execution engine, which is the normal get or like any other thing. And you have to use, beacon node, which is the consensus engine, right? So, and then there will be like, API interaction between them, right? They are actually two different softwares. Unlike in the actual diagram that I showed, where everything is inside everything, it's not easy to put, beacon node inside here or ETH1 inside beacon node. So these are two different nodes that you have to run, right? To actually get the blocks, right? And then you can run validators. Validators are very small, cheap softwares. It's like bundled. Usually what people do is that they run like 100 or 200 validators. They all connect to like one actually beacon node. And one beacon node can actually service more than one execution engine. So you can run like 5 get here, all of them connect to the beacon node. So it's like slightly complicated, but I have made it easier, assuming that there is one relationship. So you have to run execution engine and you have to run the beacon node. Both of them have to be synced. So previously you will only wait for ETH1 to get sync, please sync. It's already 5 days, please sync. So now you have to wait for consensus node also to sync, right? Because it's also a chain. And then there is like a complicated API in between which they communicate. And let's say let's say if this ETH is actually creating a block, it will give the block here, and let's say actually this validator, one validator is actually given the proposer duty. That means it has to propose a block, right? So then it will ask beacon node will ask ETH1 to give a block. It will go to the transaction memory, it will pick and some transaction, make sure it fits in a block. It will give the block to beacon node will actually put the block inside the block of the consensus node, and then beacon node will actually send to validator will actually signature, it will put its signature, and then it will be sent to beacon node will send to network, right? Slightly complicated now. After the merge, this is how your life is going to be. Okay, so yeah, prepare yourself. I'm not scaring, I'm scaring, okay. So this is another way of looking at it, right? Now some people are envisioning that, okay, why don't we just bundle it together, create something. As you know, execution engine has its own P2P. Can anybody say what is the P2P layer of get this called? Or like, is there anybody in the chat? I can't see the chat.
Someone says whisper.
Whisper? No.
Gossip?
No.
No gossip? Okay.
Okay, so it's a really old algorithm developed here. It's called Dev P2P. Dev P2P. It's actually a version of Kademlia P2P, where you actually connect with peers, and if you want to send message to some peer, you send to the peer that you know, and they forward it, and things like that. It's a slightly uncomplicated version of the actual Kademlia. And then you have like another separate module called Discovery, which actually keeps on discovering new nodes by by sending handshakes and getting it. And then if the node is good, it will come and add to your P2P list, to a list of peers that you know. And usually there is a max. Let's say max is 50, so it'll accept only 50 peers. And after that, if anybody drops, then again the discovery will provide a new peer to him. So here his peers will, he will always have peers to transmit, right? So why does execution engine use what do you call P2P? First, to receive the blocks, right? So go and receive the blocks from the peers, whether you are doing initial sync or whether you are running normally, right? So you want to get the block that is being proposed. So you actually get the block through P2P. And if you want to propose a block, or if you are a miner, you will actually create a block. And if you create a block, then you use only P2P to actually to send. You send it to all the peers, and they will see that this is a new one. So they will send it to all their peers. That's how it goes, right? So it actually goes like that. So we need actually P2P for that. Why we need P2P? I will not go much. I think you all know censorship resistant and all these kinds of stuff that we have to deal through. Possible things like plausible deniability, all these kinds of things we have to go through. So you can actually be independent, independent and this thing, what do you call, sovereign, right? So now you have a beacon node. Beacon node is also a node like get, right? So it has okay. So I will tell you an interesting thing. So when when actually Ethereum was developed first, Ethereum went for a token sale and they had some money, and then they said that, okay, let's actually start working on this. And then they started working on it. Both research and implementation went parallelly, but only inside Ethereum Foundation, right? So the first client that came was a C++ client, which is non-existent right now. And then there was one more client that that they were writing in Go. That's the Get, right? And then by seeing Get, okay, and other clients started developing on their own, right? So this model means that, okay, so there is a client by Ethereum Foundation, so I will go and get that. That is the good one, right? If you actually do that, so at least here in Get, I think Get is somewhere around 75% of all the Ethereum execution engines are Get, right? So if there is a bug in Get, it's going to affect a lot of people in the network, right? That's not good for the network, right? If let's say you have 3 clients and then you have 33%, 33%, 33% of people using them. If one client has a problem in consensus or any fork choice problem, you have other 2-1. So they will make sure that it will, you have 66% of the network up, and they will make sure that your network doesn't stall. So it's important that you actually make sure that it runs. So what they did when they started actually doing this is that they said that, okay, Ethereum Foundation, we're not going to develop anything. What we're going to do is that we are going to put a bunch of researchers, and researchers from outside also can actually come and join. And we are going to create a specification, and anybody can actually go and write a client on specification. That's how it started, right? So now they have spec for this thing, right? I mean, but if you come here, it's mostly now EIP, right? So you create a EIP 1559, and like everybody discusses, and then okay, and then fine, everybody implements it. Previously, it was not like that, not more like that. There is an EIP, yeah, internally Ethereum Foundation, they discuss, they say okay, and then they implement on Get, and rest of the engine they have to implement, right? But now I think it has become slightly democratized. But here in E2, what they make it, they actually made it much more democratized, right? They actually made it like we create spec, and any team from outside can come and create this thing. That's how Prismatic Lab started. So one guy on internet said, one guy on Reddit said, hey, I'm doing this. Anybody wants to join? Yeah, me. Yeah, me. And then like 3-4 guys, they did something. They had an MVP. They showed it, and then Ethereum Foundation give them grants. If it is good, yeah, some money for you because you did some work, and like that's how they incentivize a lot of people to actually go and write clients, right? Okay, so again, coming back to this one, so Beacon Node also has a P2P. What Beacon Node actually gives out in the P2P? Exactly the same thing, but here it's just consensus blocks, right? And what will happen slowly is that you will have a Web3 library like what you have now, Web3.eth or whatever you are using it, or like Web3.js, whatever you are using it. There will be a Web3 beacon or whatever it is, and you will have to speak with both of them to identify a lot of stuff that you want to do. Right?
Just so I understand, so the validators are running both the beacon node and the consensus engine?
Yeah, if you want to run a validator yourself, it's good to run a beacon node and execution engine yourself.
Got it. Okay.
Right. So let's say that I am an operator, or I'm a guy that I want to run like 1,000 validators. So what I do is that I create the exact setup like this beacon node execution engine 1-to-1 setup like this 3-4. and then I will attach like 250 validators to this one, 250 to this one, 250 to this one, 250 to the other one. So it's evenly spread and things like that. You can even attach 1,000. I know people attaching more than 1,000 validators to a beacon node, because validator duty is actually simple, right? You either propose a block or you attest a block. Attest and say, yeah, this block is good. Only that, right? So it's very simple. So those things you can run like this thing, and you can run with 1,000 keys. You can import 1,000 keys and say it's still one software client. You don't have to run 1,000 software clients to run 1,000 validators. It's only one validator that you will run, but you will import 1,000 keys, right? And all of these keys has to have some deposit, like 32 ETH, right? That's where it comes.
So I guess like, is there any benefit to only running the beacon node, or does it not make sense? Like you have to run the beacon node and
doesn't make sense.
Yeah.
After the merge, doesn't make sense. Now, if you run a beacon node, you are just participating as part of the consensus engine, right? So you are in the consensus engine. You will receive blocks, and you will know what is the tip of the consensus and all these things. So I think here we use like two types of consensus. One is to arrive at the tip of it. One is to do finalization. One is to arrive at the tip is called LMD ghost, which is like a it's not it's a slight variation of ghost where you have latest message delivery, or like the more latest message I have received, the more attestations that are there in the block, and all of these give me weightage to the ancestor. So that's how ancestor gets the weightage, and that's how the actual fork choice, the canonical chain, is picked up, right? So you pick up a canonical chain whose ancestor has the more attestation weights, right? And then actually the finalization is at Casper FFG. It's called friendly finality gadget. There is a huge paper on that. I don't want to go much into detail about that, but these are the two things that are actually used to come to conclusions.
Got it.
Right?
So just to make sure, so the execution engine is what's actually executing the transactions. And then the beacon node is what allows us to actually reach consensus on the blocks.
The blocks of the execution engine.
Yes. Okay.
Yes.
So right now we don't need an execution engine because the beacon node is basically producing empty blocks.
Yeah, it's not producing empty blocks.
Yes. Okay.
Right. So it's just producing empty blocks, and then it's just producing, the chain is actually moving. The chain is there. Yeah. You have a chain which is actually running there for almost a year now, more than a year now, right? So validators come in and they attest. There are a lot of validators, validator duties, assigning the validator duties, all this stuff. Now, I think I have gone past.
Yeah, it's fine. For people who can stick around, we can go a little bit over.
Yeah, I will actually leave this here and allow people to ask me questions.
Okay. I think we answered some of them as we went. So one question asked, like, is there still going to be proof of work after the merge?
Proof of work is gone. Boom. The entire industry is gone, right? You can use it for some other proof of work, like like Bitcoin or anything like that. But if you're using it for Ethereum, you can't use for Ethereum, right? So there will be something called as TDD, which is a terminal difficulty block, right? Did I say TTD? Yeah, terminal something. I don't know the full name, but it is the final difficulty, after which the difficulty will be too high for anybody to do proof of work, right? That's when it will actually do a switch to proof of stake, right? So like we are actually looking at cases where like miners will like come together and they will all like say, okay, we will do only this block, put the entire mining on here, and then somehow try to take proof of work. You can't do that.
Okay. And
So
so with one question that Sid is asking is, given that now you have to run basically two different engines, are the hardware requirements going to go up for a validator?
Actually, for validator, it's not that much. Validator is the smallest thing. You can run it in a Pi. So my guys are actually running. I have somebody who knows who is actually running, or like people report running a beacon node and validator in a Pi, pointing to so right now we use execution engine for small things like deposit. Is there any new deposit has come? So they just point to Infura and run. But when you sort of put them together, merge, then execution engine has to be closest. Now, I also know people who run entire Get on Raspberry Pi. Yeah, so I think that hardware requirements goes up slightly, but not that much.
Okay, got it. Thomas asks, right now Ethereum mining seems to be pretty centralized. How is proof of stake expected to change that?
Yeah, in actually proof of stake, it will be individuals who are actually giving this thing. Let's say you have, you have Lido and other guys who sort of do pooling. Let's say I don't have 32 ETH, but I want to join. I have 2 ETH. I can give, and like he gets from multiple people, and then they actually do it. That's pretty like it's pretty centralized in some sense. But what people are actually coming up with some like decentralized solutions, where even if you have like decentralized pools, right? Even if you have like very less, not much, I don't have 32 ETH, but I still want to be a validator. So what you can do is that you can actually go to the smart contract and then say, yeah, I'm going to join. So that pools, and then that makes 32, and then it knows that this belongs to this 5 people, and then it actually takes votes from them, and then it actually goes and deposits and actually takes care of that. So it is possible. Someone will do it, right?
Yeah.
So in that way, what will actually happen is that it's still your ETH, whether you give 32 or you give 2 or 5 or 6, it's your ETH, and you have to decide like what should I actually do with that, right? Whether should I use this beacon node and that execution engine, or should I give to this decentralized pooling system, like and it's still you, right? It's still independent people who actually give that. But in the case of there you have mining, it's actually centralized, because mining is only it gives you good revenue only only if it is centralized. Otherwise it doesn't give good revenue.
That makes sense. Does the merge happen over a single block? For example, proof of work on block N and proof of stake on block N+1, What happens to transactions still in the mempool during the transition?
The merge happens at one point. It's actually okay. I have a huge complicated diagram of how to transition into proof of merge, but it actually happens at the place where in ETH1, the difficulty becomes like after some point of time the difficulty becomes too much. So we will create a fork. We will actually add a new software. So all the people who wants to go to like proof of stake will start using the software, and that software will have things built in where after the terminal difficulty, that means the last proof of work block, it just goes down.
Okay,
right?
that makes sense. So it's over multiple blocks.
No, it's actually a single block.
Oh, it's a single block. Okay. Okay.
It's like, yeah, it's like one shot.
Right? Wow. It's going to be a scary block.
Yeah, that's why it's called TTD. Like it's called terminal transitional difficulty. So when that is reached, boom.
Yeah,
gone.
interesting.
Right.
Someone asked, why do we need execution engine when post-merge, if the execution engine is embedded into the beacon block? I think he means beacon node.
It's not embedded. It's not embedded. That's the problem. Beacon node is like separate. People have been developing beacon. It's a complicated system. So it has its own sets of issues and problems and things like that. That's what that's what a team like us do, right? So we build Prism. Prism is a beacon node, right? So Prism is a beacon node. It knows only about the the consensus spec. What the consensus spec tells us, only that's what it do. It actually doesn't know what is a block, right? I mean like what is a execution engine block will actually contain. When it needs a block, it will ask through the API, hey, give me a block. I want to, you are the proposer. I want to, do the block. So this guy will actually go to the transaction mempool, like he creates a block, he will just create a block. And previously what he used to do is that he used to send through the, PPP or like, send through the P2P node, like P2P, this thing it has, and it forgets. But now it's going to give it to the consensus engine and forget.
So I think my question is mostly around why do we need execution engines P2P after the merge? The P2P and the execution, because the block P2P.
Good question. Good question. Good question. So after the merge, the execution engine P2P will stop sending blocks, which it actually creates, but it is still required to transmit blocks across. Like, let's say if you are bringing a new system up, you have to go and connect to peers, and you have to download the blocks from peers, right? So for that, you need a P2P connection, right? So to do the syncing, initial syncing, you will need P2P. And if the sync goes down for some time, it comes up. So it uses only that, because execution engine, yeah. So execution engines have developed like complicated syncing algorithms like snap sync and all these things, right? Now, you don't want to do that in consensus engine, right? They've already done it. It's really complicated piece of software. Then syncing software is really complicated, different kinds, different this thing. So they will still use the P2P to exchange blocks which they have, among their peers. If anybody asks, hey, do you have block number 72? Oh yeah, I have, here it is, right? But they won't propose a block. Like if you attach a miner, now the miner will actually create a block and it will give you. So, I mean, a new block will not go out of execution engine. A new block will not go out of the P2P. It will not go through the P2P of the execution engine. It will be given to the beacon node. Beacon node will embed that inside the consensus block, and then we'll send the entire consensus block through the consensus P2P, right? And then they will come to a consensus on the which consensus block is the next block, and they will use the block inside that, we call it EP, execution payload, as the block that it will give it to its own execution engine. Let's say I have another one who actually gets a consensus block. So I will look at the consensus stuff, everything attestation is fine, okay. So I have an EP. EP is execution payload. So I will take the EP, I'll give it to my execution engine and ask it to do all the verification as if it has been received from P2P. The execution engine doesn't know. It thinks that it has actually received from P2P, but it will be actually, actually given through the API, and it will follow the same path that it used to travel previously. It's just, the sending and receiving is stopped.
Interesting. Yeah. From a client interaction perspective, isn't it inconvenient to interact with both the beacon and the execution engine?
Oh yeah, of course. Yes.
Yeah.
Yes.
Krishna says, can you talk about? Yeah, go ahead.
Please go ahead.
Can you talk about the protocol for choosing the validators, as well as steps and stages from a proposal of a block to finalizing the block? Like, how is 2/3 agreed determined based on stake?
Okay, so I have this like set of things after this, which you need to talk. So what usually happens in that is that in actually the beacon chain, everything is based on time. So you start at Genesis time. After that, you have a slot. A slot is 12 seconds long, and like 32 such slots become one epoch, right? And at every slot, some validator has to actually propose a block. So you will get a block exactly at every 12 seconds. Not like in a proof of work where some blocks may come at 12 seconds, some blocks may arrive at 16 seconds, and things like that. It's not like that. It's exact, right? Within this slot, somebody has to propose a block, and that block has to travel the network, and all these things. So at the end of the epoch, there is some epoch duties, right? Like okay, so epoch will go and have a look at the all the attestations that that people have done wrongly, and they will do slashing, and all these kinds of other things will be done at the end of the epoch. And epoch is also used to is to actually create a random number using a Randau algorithm, which is nothing but simple. We all save some random, and some random guy picks one guy, and that guy's random number becomes a random number, right? It's very simple. So so that Randau is used. So every block proposer will actually propose a Randau, reveal, and then at the end this will be revealed, and then one guy will take, and that's a random number. It used that random number to do the shuffling, and then to pick a set of a set of validators. Validators are usually split into committees, right? Or like 128 validators are like committee for slot 0 of next block of the next epoch, right? So let's say I actually fix this all 128 guys. one guy will be a proposer, the rest of the 127 guy will be attesters, right? So all these things will happen there, and I will give this entire list for the next epoch at this epoch itself. So a validator will know that, okay, in this epoch, I have a validator duty at slot number 12, I have to propose. At slot number 17, I have to attest. At slot number, like slot number 31, I have to attest, right? So he has to do these duties. So it is like lockstep, right? And finalization, as I said, is like, there are split into two, right? If you go into, Ethereum website, they have put this thing, you have stateness, and then you have statefulness, and then liveness, and then you have here, you have your safety, right? You can't have the, three. I think Vitalik put this thing also, trilemma, about this dilemma, trilemma, or whatever it is called, right? So you can't have all three of them. So what you do is that it's this entire entire this thing is split into two. One of them actually takes care of synchronicity and like the other one which I spoke, right? So it actually finds the the tip of the chain, because we need to know at every point, every slot, what is the tip of the chain. Because when I have a proposer duty, I have to put that guy's hash in that. So I have to know the canonical chain. So at every this thing, I will do a fork choice. The actual fork choice there is, like I said, it's called LMD Ghost. So you can go and go and read about that, right? So that actually find out the tip. So I use the tip to go across until the epoch. So at the end of epoch, I will see that all of them are done. If they have the attestation duties, most of them attesters are given that if there is 2/3 of them, I will justify that epoch. I will say that this epoch is now justified. And then again, I will go for one more epoch. Now, if that epoch is also okay, and if I going to justify the epoch, I will say, okay, the previous epoch is actually finalized and this epoch is justified, right? So things like that. So it will keep on actually moving like that, right? So you can know that after two epochs, everything is done deal for you, right? So after that, you cannot change the chain, right? The chain has reached finalization, right? So that's how it goes. I mean, it will take some time for me to explain that, but yeah, it goes in lockstep, right? You have slots, you have epochs, and then you have validators. And at the end of epoch, a system will actually create every node will actually do that. It will use the same algorithm, so everybody will have the same set of validators and like same set of this thing, because you are using the same random reveal, right? So I will know as a beacon node that, okay, what is the validator duties for the next epoch. So, and I will say that to every validator, so they will actually note it down. And when its time comes, because after 12 seconds the slot ends, when it actually knows that now it's slot number 572. So slot 572 is actually my slot. I have to propose. Then you actually it asks beacon node, hey beacon node, I want to propose. Just give me a block, right? What beacon node used to do right now is only give the consensus block. But after that, what it will do is that after merge, it will ask execution engine and ask the execution engine block, embed the block inside the consensus engine block, and then give the consensus engine block, and then it will do a signature saying, yes, it's me. And then beacon node will send it through P2P. So that, this block is like known to everybody, right? Will forks happen here? Yes. Forks happen, but it will not be as much as like what it used to happen in proof of work, because only one guy can propose, and we just have to say whether that block is actually right or wrong, right? There is no two blocks in a slot. But due to network conditions, what can happen is that a slot, a block that needs to come in my previous slot has reached only now to me, right? So I have two blocks now. So which one should I choose? And like slow, and like there are some conditions there. So there can be a split. So it's mainly because of network conditions that you will have split or fork. Otherwise, you won't have fork. And if you have fork, it's very easy to find out which fork most of the network actually supports by just looking at attestation, right?
Yeah, okay. So at the top you have like basically hundreds of thousands of validators, and then every epoch a committee of validators are chosen, and within that epoch there's slots where each of those validators has a particular duty, whether that's proposing a block or attesting a block.
All right.
Right, okay, that makes sense. That's really helpful. And then the only way that a fork happens is if two different validators here, or I'm still not sure if I understand the fork part.
See, a fork can happen if there is a validator which is not properly configured, or if it's malicious or something like that. It also proposes a block, but it's not its turn, right? It's not its turn, but it also proposes a block and tries to give it. So then everybody will say that it's not your turn, you proposed it, and they will keep a note of it. And at the end of the epoch, there'll be a slashing for that, right?
Okay.
So it, I just doubt that you can bring malicious actors to create forks, right? Because it'll be expensive for them.
Yeah.
Because if you have to have a validator, you have to put first 32 ETH inside that.
Yeah.
And then on top of that, you will have slashings on that, right? So it's actually economically hard to actually do that. But there are some vectors and all these things. I mean, this is more into research and things like that. But in all practical conditions, the fork can happen because that a block that needs to reach me previously, let's say I'm a proposer, I have to propose now. My machine is like CPU full or whatever it is, or my entire bandwidth is slow or whatever it is. I tried to propose a block in this slot, but that block actually traveled through the network and reached another guy in a different slot, right? So then that guy, if both of them actually point to the same parent, and because there will be other guy who would have actually created a block at that time, because that is his duty. So you have like A, and then you have like an empty slot, and then you have like a B and C in the same slot. Both are pointing to the same parent because B's actual parent is A. And now since I mean, in this slot, nobody proposed, the actual validator who proposed in the third slot assumes that that's a skipped slot. It assumes that the validator is not there. It's offline or whatever it is. And it produces a block called C and puts the parent as A, because that's what it knows. It doesn't know about block B. Now block B arrives in some part of the network. You will have A and B. In some part, you will have A and C. Now there is a fork. Now, if in the next slot, if the validator that actually picks B or C, right? It has an option to pick B or C because both are canonical, right? both have the tips, right? Good tips. But then you will actually look at how many people attested it, right? So
Okay.
you add sort of something called as weightage, right? That's why it's called LMD. It's called latest message delivery or something like that.
Yeah.
So it's you give more weightage to something which you received latest. So then people will start picking C, and then it will go like that. So it will be an since you didn't propose properly at that block, it will be a skipped block for you, and you will be slashed. Or if you if you actually didn't propose at all, then you don't have a problem. You just skipped block. Then you create a new block C here. That will be a parent of A, and then you just go on.
So
The
if
only time you can have splits, but then you will have the, I mean, you will have reorgs very fast. It not go like long, like, like 50 or 60. Long reorgs are very hard conditions, very hard to simulate, very hard to actually get in real world conditions. So
yeah, that makes a lot of
unless
sense.
if there is a consensus bug or like fork choice bug or whatever it is.
So then, like, if I guess so, if validators are assigned to a particular slot, whether they're proposing or attesting that block or in that slot, if they're offline, they get slashed. They get punished for being offline.
Yeah, they get punished. So it happened like this in the initial version that they released. The punishments were small, and in the last hard fork, Altair, we slowly increased the punishments, right? And now when we are going to do the merge, it's called Bellatrix. It's actually named Bellatrix fork internally. So so when we actually release Bellatrix, this will be like tuned on like to the actual, actual mainnet conditions, right? So the slashings will be more for people, right? So the percentage of slashings will be more. Initially, it was very small amount of slashings, and then we increased the slashing in the last hard fork. Now, when we go for Bellatrix, we will just make it like full throttle. It's a slashing that will hurt you, right?
Got
Kind
it.
of.
So then for each block, for each block, it has to point to a parent block. So consensus can't be reached within the context of a single block. It has to point to a parent.
Oh
Is that
yeah, I
right?
mean it's again a blockchain. The consensus
Yes. Okay.
thing is also a
'Cause,
blockchain.
Yeah,
Right?
I asked because Vitalik kind of wrote about how there's also a BFT style proof of stake where consensus could be reached on a block by block basis.
Yeah, so this is okay. So if you actually now go into other this thing, that's what I used to say, right? So you have other kind of proof of stakes where not all members can become validators, right? Let's take let's take Facebook. I mean, I can bash Facebook, not a problem. So let's take Libra, right? So Libra, they said initially we're a consortium of like 40 MNCs or like whatever big companies, and each of them will run a validator. And what I was like, okay, so you 40 guys are going to decide what the next block is. So other guys are not common. It is like saying, okay, you can only vote if your entire net worth is more than 1 million. It's like that, right? But in Ethereum, it's like anybody who has 32 ETH, anybody can vote, can become a validator, can say, yeah, I will verify the network. I will make sure the network is right. I will report if there is any, anybody who has not done it properly. I will do all these duties, right? So I will abide by this, and only then I get incentivized slightly, right? So I mean, there is incentivization. Why should I become validator? Because you will get incentivized. So things that goes to miners today will come to you, will come to people,
Yeah.
will be distributed to all the validators. Like there are like 300K right now, right? So many people are actually running beacon nodes, and so many these things and everything. It's just that you have to run this together is slightly complicated now. This is because you know I think actually the community came to the decision because we want to release merge and make sure that we go to sharding. When I say sharding, data sharding, because when you do that, you enable all layer twos to have more capacity, right? So that's how you increase the capacity of Ethereum as a whole, as an ecosystem. So
Yeah.
each tool, this entire sharding, nothing is going to increase capacity for you. It's still going to be 14 or 15 transactions per second. But what will increase the scaling capacity is that even when you enable data sharding, when you actually put this into a shard, let's say there will be one more small thing running, or a beacon node can run shards, right? So it can actually store stuff, more stuff, and that's how you do that. And from the other side, there are like there are new things that are coming, that I don't have to go and report everything to layer one. Instead, I can actually do something I call roll up, and then I can give some, I can actually put my signature, and then I go and give to the layer one, and still get the security of the layer one, but I get more capacity also, right? So that's from the other direction, from layer two direction. That's where I think it's coming slowly. These two will merge, right? There are people. I mean, when we were designing Engine API, what you see here, we were also thinking about how this can be used with a layer two. A layer two can, if it wants to query what is the consensus status and all these things, can it use the can it use the same API and things like that. You're thinking about all these things, right? So what Ethereum as a system will do is that it will not do scalable. It will not actually solve scalability problem. It will just enable other systems to solve scalability problems, like layer twos, right? You have to do out of band. You can't have one Supreme Court and no other court in the country. You have to have a Supreme Court, or the court which is in the top, and have a lot of high courts in every state court or district court or whatever it is. If you have problem, you go to high court. If you have problem there, you go to the ETH1, which is the Supreme Court, which is the guy which can actually say yes or no, right? Based on that, you take decision whether to slash or not slash. If you are validator based, it's your stuff. It's up to layer two, right? But I can give you the security and the like scalability in terms of data, not execution, right? Execution sharding is something else. So it's a pretty, I mean, if you bring execution sharding, that's like 2025, 26 roadmap.
So with when we shard the data, there's going to be validators for separate validators for each shard, I'm assuming.
Yeah, there will be, I mean, there will be actually a committee formed. Right now itself, if you see that for a slot, you will have more, you can have more than one committee, because you have you have like 300K validators, right? So what you can do is that for each, okay, at least in the simplest case, I'll explain simplest case. For a single slot, you will have, if you have 64 shards, you will have 64 validator committees. And for each one of them, there will be a block proposal, right?
Ah, okay. Interesting. Very cool.
And then
We'll
each one of them will attest on the data and all this kind of thing.
yeah.
So it's you can have committees for that, right?
Yeah.
So yeah, so right now we have something called as other committees, which is it's called sync committees. It's mostly for light clients. So you just actually give only only the only the Merkle root, or like not the root, the tree, right? The branches through which it falls. Only you give that. You don't give the entire data, and then all these guys have to attest that yeah, this is right, and then it can give to light client. Light client can blindly use it because so many people have attested it, right? So it doesn't need to actually store anything. That's another thing that has been done in the last hard fork.
Interesting. We'll take like one or two more questions. Talita asks, what happens to the ETH that's slashed? Is it burned?
Good question. I think it's burned, yes.
Okay. How are the rewards and interest paid for staking predicted over time?
I don't know the exact implementation or exact formula on how they are actually calculating to give you incentives, but there is a formula based on how much is the network fee and all these things, base fee, and all these things that are there. Based on that, there is a formula that actually creates and looks at all the validators that have attested correctly and split it for them.
Got it. Interesting.
I don't know about the implementation details, but there is. I mean, you can look at the spec. No, right? You can go to Ethereum/consensus spec, and then you have all the specification there. So you can read it. I mean, that would be like the first stop. But hello, can you guys hear me?
Yeah, I can hear you.
Sorry, I lost my power. Sorry.
Yeah, I think that kind of wraps up all the questions. We have a lot more questions, but in the interest of time, I'm going to start to wrap it. We can wrap it up. If people want to, you said if people want to learn more about it, where can they read the spec?
Okay, so I would actually recommend something called this. I mean, just search for ETH2 annotated spec by Ben. Right, annotated spec by Ben. I think I think that's the closest verbose spec I have got for ETH2. Otherwise, the general ETH2 spec is like very bland. I mean, you can see like few Python snippets and then something on top. That's it. It's very hard to understand that spec.
Yeah.
I don't want to actually discourage people, but I think annotated spec by Ben is one good thing. I think Vitalik also has an annotated spec, but I didn't read that. It's again, he speaks, he speaks on a different level. So I went for Ben, and then I understood what actually happens. And then the best place is to go is to actually run the software yourself and find out. Look at some of the clients. Like Prism is, of course, one of the clients. If people like Go, they can understand Golang. Like Prism is one of the clients. It used a lot of things that is there already in Ethereum. And people have actually written clients in like Rust. It's called Lighthouse, and there is in Java by consensus guys. It's called Tiku or something. And there are other clients also.
Okay, awesome. We'll take a look. And then
code, I would say, look at the code, look at the fork choice. What is the problem? What is how it changes, fork choice changes. I think that's the biggest thing, right? So after the merge, this old fork choice is gone. It depends on the consensus client to do fork choice for itself, the execution client, right? So fork choice is something that you can look at. Yeah, there are a lot of other materials also. I think, I mean, I have list, maybe I can send you, I don't know.
I think, Preeti should also update your blog, right? How does Ethereum work anyway, just in time before the merge, so that it becomes
Sorry?
a good source.
Sorry?
yeah, I need to
So
write
Preeti
like
has a blog.
yeah, I probably need to write
Yeah.
like how does proof of stake work article.
There's a lot of change that's
Yeah.
happening right now. And there's something called as optimistic sync that I'm working right now with my team members, which is like a case where your EL is syncing and your CL is up and running, and you are getting blocks from there, and you have EPs on that, right? And you want to, you can't actually verify the EP, which is execution payload, right? And how do I actually do this in this case? So these are something, there are like corner cases, lot of cases, lot of things can go wrong in this. This is the most complicated thing that I think that we'll do, I guess.
Awesome.
If I do that, I will say that this will be the most complicated thing that I have done in the last 25 years. Yes.
That's quite a statement.
Yes.
Awesome. Thanks, Zahoor, for dropping all of your insights and knowledge about E2 with us. It was definitely helpful for us all. And then we'll share the recording and the slides with the group who wants to review it or whatnot. But yeah, thank you again. This was immensely helpful.
No problem. No problem. I like, speaking to people, especially, people who are like eager to learn about Web3. I like to speak more. I think I wanted to speak for only 30 minutes, but
Yeah.
it's gone too far. I'm really sorry for that. I'm really notoriously known for not keeping time in presentations. I get involved so much that I sort of try to give as much information as possible for people to, at least if you don't take anything, at least you take all these things in mind. Like I have heard beacon node, I have heard some, LMD ghost. What is that? I heard, this thing, what do you call it? I have heard a Casper. What is Casper FFG? Things like this. Go and look at it, or like go and look at what is a slot in ETH2. What is an epoch? What are actually the duties of a validator? All these things. So you have like beacon node, validator, all these things interacting. So this entire setup, right? I think it's important for you guys to know, right? When you speak about ETH2, this is where it will land. This is how it will be, right? Yeah, whether you like it or not, you have to run get and beacon node together, together in one piece of infrastructure. And you can have validators outside. It's not a problem. But these two has to be, your own. You can't just point to Infura. People point to Infura and actually, try to do things now. But now you can't. Or either Infura will actually provide I will give you a beacon node API and all these things. Yeah, if you don't believe anybody, or I mean, like if you believe in Infura for everything, fine. You stake using Infura. Then if there is any problem in Infura goes down for 10 hours, you will be slashed, right? Infura won't be slashed. Your money is gone, right? So you have to run your own system. That's more important. We have especially, we are very, very careful every time that we don't exceed certain memory limits and CPU limits, whatever it may be, right? We could do things in very simple things, but we are, today thinking about algorithms which are super complicated, but it saves lot of memory, right? So that's where all the research goes in implementation.
That's
apart
fascinating.
from the research other guys do.
That's a really
Right. So
interesting
yeah,
point.
I have my Twitter handle, J Mohamed Zahoor, or you can just search for Mohamed Zahoor, whatever it is, or Ethereum Zahoor. There is another Zahoor who is a billionaire in UK. So he will show up if you search just Zahoor. So you search Ethereum Zahoor, Mohamed Zahoor, whatever it is, you will get it. And yeah, my DMs are open. You can ask questions.
Yeah. Thank you. Really appreciate it. Have a good night.
Thanks.